Hi guys, I know it's been a long day. So I'll try to keep this. Unfortunately, my presentation was a technical presentation because I thought it was Infracon. So I thought like, hey, you guys want to learn about the infrastructure. So it is a technical presentation, but I'll try to make it as interactive as possible. I'll kind of like go through what I wanted to go through, and then we'll open up for Q&A, and it will be nice and cool. So for those of you who don't know who Web3Auth or what Web3Auth is, I'm the co-founder of Web3Auth, and what we do is we are basically kind of like Auth0, but for Web3. So what we do is we replace seed phrases with a multi-factor key, which is powered by MPC. A multi-factor key is, as it sounds, it's very similar to multi-factor authentication, where a user can use different things that they own, for example, a device, social logins like Google, Facebook, or whatever, and other things to basically secure their public-private key pair. And you need a threshold number of them to access the key. So that's what we do, and we've been around for about 3 or 4 years, right? 3 years or so. And at the start, there was barely anybody using us. 1 year in, we had about maybe 100K, 200K users a month. Earlier this year, we had 1 million users a month, and now we have maybe about like 7 million users a month. So we built our initial MVP and our initial product, not really MVP, but our initial product out 3 years ago. So it really was not keeping up. And we were basically at 7 million users a month right now. The infrastructure handles maybe about 200 million users a month at max capacity at this point in time. There are also some issues, there are other issues with our current infrastructure stack. So the logins that we were doing across the world were across the world. And basically, because of our system and the fact that we needed consensus on our system, we had to kind of like centralize clusters at different regions. Today we have 3 clusters, one in Singapore, one in India, and one in the US. And login times at those regions are okay and pretty good, under 2 seconds. But if you are in South America, for example, if you tried logging in with Web3Auth, it can take up to 5 seconds, 6 seconds at sometimes. And that's not according to user expectation, right? So not just that, our infrastructure today doesn't scale up or down. So it's not so easy to scale consensus structures. Because you need consensus on them. With Pocket Network, it can scale up and down according to how many nodes you have. But for us, when it comes to key management, you want the same node operators, for example, like providing your security. So people running nodes on Web3Auth today are like Binance, Ethereum Name Service, Etherscan, all these people, right? But there's a consensus system, and basically it's really hard to scale it up or down because that means Binance, ENS, and all have to scale their systems up and down and run more nodes or like improve resources on the current node setups. So I'm just going to go through our current infrastructure and then our new infrastructure and then some of the lessons that we learned in improving our infrastructure stack. And then I'll take some questions because I think it's not super exciting. So this is our old infrastructure setup. And it used to be called the Taurus network. We used to be called Taurus for those who don't know. So you have your different nodes, and the nodes would interact with different apps on the front end. There was a registrar on Ethereum for the nodes. And basically, this is the setup here. So you can see that each of our node operators, so Binance operates a node, Ethereum Name Service operates a node, we run one node, and it's like a 5-9 structure in today's system. Each of these are like a single, like a 2-server setup. So there's like a 2-service setup where there's your consensus layer and then there's your logical layer. And it's built off Tendermint. So built off Tendermint, Cosmos Tendermint, and that's the BFT layer that we use to coordinate between all of the different nodes to agree that a user has authenticated correctly via Google or Facebook or whatever. Now, From this infrastructure, you can see that we can't just ask more node operators to come on board because that doesn't improve performance in our system. It might in some networks, but it doesn't in our setup. And the only way is to actually internally scale the nodes themselves. So our new infrastructure today looks a little bit more like this. This is one node. This is one node. So this is one, and there are maybe like 30 or 40 of them running, and you'll choose a subset of nodes to secure your application. Now, this one node is actually not a single server, as it would be typical, or a single node, as would be typical for a blockchain project. For us, this one node actually needs to operate like a full cloud setup. And what that consists of is first a coordinator service. So this coordinator coordinates multiple cube clusters. So we will operate in like N regions, so 6 or 7 regions. And for each region, a node operator would run a cube cluster, which would then have a microservice architecture and spin out and spin down services as necessary, very similar to ECS on AWS or any one of those managed services. And as you can see, so one node runs 7 cube clusters across the world with its own coordinator setup, where the consensus lives up here in the coordinator setup. And you can see that it's quite a maybe almost unnecessary infrastructure and architecture upgrade because it's and then you have like 40 nodes. So yes, each node runs at least 20 instances, and then you just times that by 40. So it's a lot of instances, but it's what we needed to do to achieve both horizontal scalability as well as geo latency. So these are regionally distributed, and so now we are available in 7 regions, so that login times, no matter where you are in the world, is under 2 seconds. And if there's spikes in traffic, for example, if there's the NFL, or if there's a huge NFT drop and you need a really large spike in traffic, the cube clusters just horizontally scale themselves. And the whole node structure horizontally scales itself to adapt to it. So we progressed from that old architecture to this new architecture this year. And here are some of the experiences, just to share of our experience of doing that. Most cube cluster management services are centralized. Multi-cube is a structure that exists and is popular in Web 2. Not super popular, but relatively popular, like maybe Netflix uses it, and some other large companies. And there are services like, and there are services like Rampa and others which help you manage multi-cube clusters. But they are always enterprise solutions, and you always have to pay for them, and they're always managed by somebody else, and it's centralized. So we couldn't do that. That's just a fun thing to know. Geo latency DNS servers aren't the same across different providers. So when you're talking to different, I mean, that's kind of obvious, but we need to, because the important thing about geo latency servers are basically servers that route traffic from a user's front end to the appropriate cluster. So you go through one endpoint, but you might hit N number of services behind it, depending on where you're closest to, right? And for us, the user needs to talk to 9 nodes or 5 nodes at the same time. And they need to talk to the same regional cluster for those nodes. So it's just important to be aware that AWS, GCP, or all the other DNS service providers, they provide different types of geo latency routing. And we had to basically build that ourselves because we couldn't use their DNS routes. So the third one is the infrastructure and moving to this sort of setup is a bit of a DevOps nightmare. There's really a lot of config to deal with, and config can break quite often. You really do need a good DevOps team. So, I mean, that's all I had for today, really. And any questions about this and anything, really?
So you talked about how you improve the nodes, but the solution is more about the nodes. Do you see any other kind of bottlenecks or limitations other than just the nodes in the solution?
Was your question, are there alternative architectures from scaling the nodes? Or
Yeah. On your first slide, there were more than the nodes on your solution.
like this?
Yeah.
Oh,
Are there any kind of limitations where if you improve the nodes, it doesn't improve the overall solution because there are other kind of bottlenecks in the system?
right. Well, not really. Our main bottleneck was our infrastructure behind the scenes and the fact that it needed to be everywhere. So, yeah, the three things that we wanted to fix was improving the number, like handling the number of users, scaling up and down so that we didn't pay so much AWS costs, or GCP costs, or any cloud provider costs, or our nodes weren't suffering, and then logins across the world. So, I mean, like the other parts of the infrastructure are more to do with like the front end, and how a user kind of reconstructs and gets back their key, or in the case of just uses their key in a MPC setting. I do believe, like for us, the bottleneck was really the node setup.
Okay, thank you.
Hi, I'm wondering if you can talk a little bit about how the cost has changed from the old infrastructure to the new infrastructure, both in the average case and the worst case, and then overall, but also per login, let's say. Like, has it gotten cheaper, or it's gotten more expensive, but maybe the service is better now?
Yep, absolutely. So, like with the old infrastructure, because it was static in terms of nodes, like, although even if we increased the node count, we wouldn't be able to provide more logins or have better latency. And because of that, to cater to like 200 million users that our old infrastructure would cater to, right? We had to right off the bat, like pay for like very heavy compute and really heavy instances because they weren't horizontally scalable. Which means that we were just paying a constant amount throughout, and we could upgrade and swap instances, but it would be like a step function, right? We would start 100 million, then 200 million, because it would take like a couple of weeks to swap instances. So the biggest problem was that, so that means you pay the same amount of constant fees, the max that your network can provide to AWS at any point in time, even though that CPU or those logins weren't used, right? And that was the main cost saving. So the new infrastructure actually has more overheads. It actually costs more, it has more flat costs because of the managed cube and because of the additional instances required to coordinate and across the different regions. Because of that, there's a higher initial fixed cost and overhead. But with regards to logins, this now scales up and down. So for example, right now we aren't getting much traffic from the African region. So right now we have a setup, but it's basically costing us $50 a month, right? It's nothing. So, but we are prepared to scale for African users if the case arises. So that's really where the cost savings come from. For a per unit cost, it hasn't changed much per login for the flexible cost, yeah.
Yeah, pretty fundamental infrastructure change here.
Yeah.
How long did it take you to make this change, and what was the toughest challenge?
A year. It took us a good year, a good year from like architecting it to actually implementation and the upgrade. I think the hardest issue was really building a team that knew Cube in and out. DevOps was the most difficult thing, and I can't stand it. I hate DevOps. Like the amount of scripts you have to go through, and like the bug is just one little space too long in your YAML. It was ultimately DevOps config management that took the most time, more than anything. Yeah, and as your infrastructure gets to this scale, when you're talking about testing, that's also a big problem that we faced, and we haven't solved it, to be honest. Like, because how do you test this setup, right? To test the setup, you have to spin up 9 nodes in different regions to test the setup. So like, even in your test clusters, you take your iteration timing to test something is at least 12 hours, right? And it's something we're trying to reduce now, but those I would say have been our biggest blockers.
Did you consider other alternatives to Cube, like Nomad from HashiCorp?
We explored Nomad a little bit, but Nomad can be quite expensive, and there's less open source documentation on it. So even we had some people. I was for Cube, but we had some people internally that were vouching for Nomad, and in particular, the main problem of that is that if we did Nomad, like, you would have 2 or 3 people who knew Nomad on the team, and we wouldn't be able to hire anybody else to help us out because nobody knows Nomad. And then you would have to pay HashiCorp, right, to help you out. And that's not what we wanted to do. We explored not using Cube. So we explored using like more base layer Docker orchestration, like Docker Swarm, and just basically actually like doing it ourselves, right? Doing orchestration ourselves, because Cube actually has quite a bit of overhead. But in the end, I think what we realized was Cube was actually helping us out a lot on a lot of the config management, and that was one of the biggest points. And the second point is a lot of the work that we would have to do with like Docker Swarm and everything we would still need to do with Docker Swarm and all, even with Cube. Like, for example, a lot of it was VPN peering, so between the nodes, like VPC pairings, I mean. Let's see, what else did we have to do? It was like load balancer routing, the geo latency stuff, which was a major headache. And that stuff we would just have, it would be the same with Cube or Docker Swarm. So Cube, in the end, did save us a lot of time. Okay. All right. Thank you, everybody. Thanks for having me. Oh, by the way, if you guys are a DevOps nut, it's gone, but you can Google us. We're always hiring for DevOps. If you're a DevOps nut and you want to play with this type of DevOps infrastructure, which is relatively fun to play with, you click a button and then like 20 instances pop up. Hit us up.